start. So, welcome everyone to this Men&Mice webinar. My name is Peter Pettersson, and with me today I have Carsten Strotmann from our services team. Today's webinar is focused on the last IETF meeting taking place in Toronto, Canada, on July 21st through 25th. Carsten, I believe you did not attend in person, but you were like attending through online sessions, was it?
Yes, correct. This time I couldn't go to Toronto, although I would like to, but it wasn't possible. Too much work today, or this July.
No problem. But you picked up the best pieces there, and you're sharing it with us today. So for those of you that are online now, please note that you're in like a read-only mode. There is a control panel in the GoToMeeting application where you can submit your questions, and we will address these questions at the end of the webinar. Please note also that we are recording this session, and you can find the webinar along with the slides at our website within a few days. And at our website, you can also find recordings and slides from our previous webinars. So if you drop off this call for any reason, you can take advantage of this recording, viewing it from where you dropped off. So without further ado, yeah, let's just start the webinar. Carsten, the audience is yours.
Thank you. So hello, welcome everybody to this IETF review, IETF 90. And for those who haven't been in contact with the IETF, or the Internet Engineering Task Force, is a group of people that work on online on mailing lists and also face-to-face on IETF meetings to create the Internet protocols that we all use and that run the Internet, as we know. And I've been remote attending the IETF in Toronto that was held in July, end of July. And I collected some interesting bits and pieces from DNS, DNSSEC, DHCP, and IPv6 along the way. The IETF meetings are huge. They are large. They are probably maybe 500 sessions going on. So it is not possible to cover everything that is in there. And I had to make some choices here, and I probably left out some interesting bits. But I hope what I collect for you is of interest. I've left out the Dane stuff. Dane is a new protocol that secures encrypted connections and the certificates being used there. And we will have a full 1-hour webinar going in detail on what Dane is and about the latest news on Dane in the IETF in September, which is our next webinar. And I wanted to not duplicate too much content. So if you are interested in Dane, please join us in September there. So first, some generic news or RFCs, some new standard documents. And the first one that I want to present here is RFC 7282, which is about how the IETF works internally. And the IETF, compared to other standard bodies, is quite unusual in the way how they work. There's no membership. Everybody can join in and work, and you don't have to register. You just have to appear or join into the mailing list. And so the way how the standards are coming into place and how consensus is being reached is different than in other groups. And this RFC explains a little bit how it works, how, for example, rough consensus is achieved, and some other interesting stuff. That document is an interesting read, I think, for everyone who works in a group and sometimes need, like in a technical group with IT people, with networking people, and need to reach consensus among these people. And it might have some good ideas in there. Also, if you're, of course, you're interested in working with the IETF, this is a good document to read as well, to understand how these standards are being discussed and defined and how consensus is being reached. And another important RFC that has been published in May is RFC 7258, and this is in the light of the documents that Edward Snowden revealed to the world about the monitoring going on in the internet by different organizations. And now the IETF with this RFC sees the pervasive monitoring as an attack. The RFC itself is a best practice document, best current practice, BCP, and what the publishing of this RFC means is that new protocol designs that are being developed in the IETF will have countermeasures against monitoring built in. So while, for example, encryption was like optional in many protocols in the past, it probably is now mandatory for new protocols being designed going forward, which is an interesting development. So first topic I dive in is DNS, the domain name system. And we have three RFCs that have been published since the last IETF that have some impact on DNS. The first is the Sender Policy Framework. That is about the SPF records, which can be used to authenticate the sender of email, and by doing that reduce spam. Now the big difference here between the previous RFC describing Sender Policy Framework and this one is now that now SPF is in the standard tracks, while before it was just an experimental RFC. Now SPF is, has much higher value in the suite of protocols in the IETF to use. Then there's an RFC about Dane, specifying some acronyms to be used in Dane, and we covered that in the September webinar. And the last one is an extension mechanism for the expire option, and that is an experimental new RFC, an extension to DNS that allows a secondary DNS server that receives a zone from another secondary to get the expire counter from that server. The reason here is if there is a chain of secondaries, like there is the primary master, and then there's the first level of secondaries that directly talk to the primary master, and then there's a next level of secondaries that just talk to the first level of secondaries. If a zone expires there, it can take the double amount of time of the expire that is specified in the SOA record until the zone is disappearing from the last second level secondaries. With this extension mechanism, the expire counter from the source DNS server from the like first level secondary can be read and can be directly used by the receiving DNS server, so making sure that every secondary has the same or almost the same expire counter, and that a zone will expire at the same point of time, no matter where in the secondary hierarchy it is. As this RFC is being written by Mark Andrews from IC, I expect that to be implemented in Bind rather soon. So probably one of the next versions of Bind will have that expire option built in. Then the DNS Operation Working Group, which is the main working group inside the IETF where DNS work is being done. They have changed the charter to make it possible to tweak the existing DNS protocols. In the past, there were two working groups in the IETF. There was the DNS Extension Working Group, which was working on new DNS stuff, and there was the DNS operations working group, which was working on operational issues like how to operate DNS. The DNS extension working group has shut down last year, leaving the DNS operation working group the only DNS related working group, or the main DNS working group in the IETF. And now with this charter update, DNS operations can make changes to the existing DNS protocols, which is sometimes needed, as still new developments require new protocol enhancements to DNS, like new resource records or maybe new flags in there. However, DNS operations will not do completely new DNS protocols. So like something as DNSSEC, doing something as important like that will not be in DNS operations working group. If that is necessary at any point of time, probably a new working group exactly for that purpose will be chartered. So coming to the topics being discussed in DNS operations working group, there's a draft on DNSSEC key timing, which explains the timing issues when doing key rollovers in DNSSEC. So when to publish, activate, deactivate, and remove DNSSEC key material from a zone. And that document has been updated to version 4, and the diagrams have been updated, or some new has been added, and the text has been updated to reflect the key states better. And there will be a working group last call on this one, and if there's no objections and no issues being found, it's very likely that this draft will then advance to an RFC state. And another document being discussed is the resolver priming. This is about the queries a DNS resolver needs to do in order to fill its cache with the root zones, NS records, and the IP addresses, both IPv4 and IPv6 addresses of the authoritative name service for the root zone. Now, this is something that every DNS resolver does since the dawn of time. Like all the bind name servers, Unbound, Microsoft DNS, they do that, but nobody has really written down what is required, how to do this. So for new implementations, also make sure that all implementations do the same stuff. This document is there. It's quite an old document, started in, I think, 2007, and it still has some open issues, and there was a call by Peter Koch, who is the main author of this document, to have a review on this document and work on the open issues and make it ready for publication. New stuff. A draft by Warren Kumari from Google about securely distributing the DNS root. And the idea here is to give every DNS resolver, that is every DNS server that acts as a resolver for client machines, give every resolver a copy of the root zone. The root zone is not really large. It contains all the delegations to the top-level domains and the IP addresses, the so-called glue records for the name server entries. So overall, compared to today's computer sizes and memory, the root zone is not really large. So it would be possible to give every DNS resolver a copy of the root zone. Either ship it with the software or make it available by zone transfer. And even that's available today. You can do a zone transfer from the froot name servers, the root name servers operated by ISC. And then you can build a root zone in your server. Why would anyone want to do this? So the benefits would be that there would be less junk queries to the real DNS root zones. Every typo today in a web browser, a typo inside the domain name part of the URL, will hit the root name server system. So it will go first to the quote local DNS resolver, and that resolver will find no entry in its cache. It will ask the root name server system, and the root name server will likely answer with an NX domain. If the DNS resolver already has a root zone, it can authoritatively answer with NX domain directly, which is both faster and saves the round trip time to the root name server. So it's less traffic less junk queries going to the root name servers, and it's faster for the users. Research on the root name server system has shown that about 90% of all queries going to the root name server system is these kind of junk queries. So a lot of unnecessary traffic can be spared here. Another benefit would be that the DNS resolvers can operate even if the DNS root name server system in the internet is under a denial of service attack, because it's completely then independent of the root zone, because it has its own copy. And privacy. Today, a DNS resolver asks the full question. So if I go to, let's say, myfancywebsite.com, and that name is not in the DNS resolver's cache, neither is the delegation to the com zone, then that request will go to the root name server. And whoever does some monitoring on the root name server will see that I'm asking for this name, and there's some kind of information that can be read there. If the root zone would be local on any DNS resolver, these queries would not go out, would just be answered locally, and so it would less information would be available for monitoring on the root name server system. However, it's not all positive. There are some issues with that, meaning that DNS resolver software would become more complex because they would have this full root zone in there. No monitoring means no monitoring. Monitoring can be used for good and bad. No central monitoring also means that the technical community gets less information about what's being requested on the DNS. Root zone changes would propagate slowly. If today there's an error in the root zone, it can be fixed rather quickly by just changing the content, and then depending on the time to live of that entry, it will propagate to the caches. If every DNS resolver has its own copy, then propagation would be more slow. And it would change the nature of traffic hitting the internet root name servers, because all the good traffic would then be handled locally. Only the bad resolvers, the misconfigured resolvers, will probably go to the real internet root, which might be good or bad depending on how you look at it. So this was an interesting document, and a lot of discussion on the mailing list and also in the room resulted from this. And it's nowhere near of having consensus. So it is at this point of time just a document that started the discussion, and we'll see where it leads. In a similar direction, but not quite, was another proposal about scaling the root name server system. And this is about the restriction of 13 root name servers. Today we have 13 IP addresses and names for the root name server system, and that has historical reasons in IPv4 UDP. When DNS was designed in the 1980s, the maximum payload that was guaranteed to never fragment on the way was 512 byte. So the number of DNS servers in the internet for the root zone was restricted to 13 because 13 names and 13 IPv4 addresses just fit nicely in 512 byte. Today, this restriction is not so relevant anymore. We have IPv6. Also, in modern IPv4 environments, we have Ethernet everywhere, and the maximum transfer unit of Ethernet is 1,500. So we have more than 512. And the guaranteed, or the minimum guaranteed MTU of IPv6 is 1,280. So we can have more root name servers now because we can have larger answer packages. Up to 20 DNS root name servers are now possible. The question is where to place the 7 new ones. And the author of this document gives some ideas what to do with the 7 new ones. I must admit that I haven't fully understand this proposal, but what I understood is that it should be possible with the 7 new ones to have like local administrated copies in different countries, regions that have then some specialties, still serving the same root zone, because the root zone is DNSSEC signed and therefore cannot be changed, which is good. But having different delegation sets in there to be able to do some traffic engineering. So if you're interested in getting the details, I invite you to look at that draft document. And then there was a third presentation and proposal, which is also about the root name servers, but this was more like how to calculate an optimal placement for authoritative DNS servers. Now, this is about if you know that you have a number of data centers, and you know the processing capacity of the servers in the data centers, like how many queries per second DNS servers in their data centers can achieve. You know the latency, like the round-trip time from the clients. You know where the clients are in the network topology. You also have the deployment cost, how to calculate the best placement, the optimal placements for the authoritative DNS servers based on these information. And the author of this draft presented this slide, of this picture from the slide, which gave a little laugh on in the room, because it's the headline doesn't really fit the number here, at least for non-mathematicians. It's not a simple example, but it's a serious business here, and the outcome is very interesting, to be able to calculate where's the best location to place name servers. And the authors have done that for a network in China. So they have here the result that they presented with the formula that they created. So here we see if only one node is possible. So if we can only deploy one DNS server, then the selected location would be Beijing, because the majority of clients would be there. And then if we have two, best selection would be Beijing and Sichuan. And with 3 and 4 and 5, you see the numbers there. So if you're interested in that formula, you can look at that draft and that presentation. It's quite interesting. Matthias Mecking from NLNet Labs had a proposal on creating a common data format describing a DNSSEC key and signing policy. Key and signing policy is for DNSSEC, for DNSSEC signing system, a policy that describes the validity of the signatures, whether to use NSEC or NSEC3, key sizes and key algorithms, the signing scheme, like double key rollovers or pre-publication key rollovers, like that. And currently, all the different tools, either open source or commercial tools, use a different data format, and it's not possible to import-export a policy between products. And the idea here is to have a common standardized data format in the YANG description language, which is an IETF description language for data, very similar to JSON, and to make it then possible to describe such a key and signing policy. We see if there are some vendors having interest in implementing this and bringing this forward. This comes more or less from the Open DNSSEC people. They already have such a key and signing policy, although in XML, and it would be interesting, for example, to be able to exchange such a policy between Microsoft DNS Server, which have a key and signing policy, and Open DNSSEC and other products on the market. And then there was a presentation about reverse DNS pointer records in IPv6 for internet service providers. This is about that service providers cannot pre-populate all the pointer records for a customer, as it is sometimes done for IPv4. Lee Howard from Time Warner Cable, who presented this, calculated that it would take 38 trillion years to populate a single /64 with pointer records for just one customer. Nobody can do that. And this draft now discusses alternatives, what to do as an internet service provider. So you could do no pointer records at all, which would be no response. You can have a wildcard match, just returning the same answer no matter what is being requested. You can use dynamic DNS so that the host that owns an IP address registers its own host name to the IP address in DNS. Could be done that the problem is just being delegated to the customer, like the ISP delegates to the customer's DNS, and the customer has then the work to populate the pointer records correctly. Or pointer records can be generated on the fly from some database, IP address management database, for example. And the document describes the pros and cons of each alternative here. And the last one for DNS is the multicast reverse mapping. This is about having well-known DNS names for multicast addresses. This exists already for IPv4, but it is in a not so good shape because it has been done ad hoc without having a real standards document. So this proposes to fix the IPv4 naming and provide a sane IPv6 naming on the way that matches the IPv4 naming. So here we see how IPv4 multicast reverse is done today. If we ask for the name for 224.0.1.1, which is NTP, Network Time Protocol, for IPv4, we see that the name is ntp.mcast.net, and the proposal here is to move multicast from .net to .arpa because it is an infrastructure service very similar to the pointer records and E164 and other stuff. So it should move from .net, which is a generic top-level domain, to the infrastructure domain ARPA. And then for IPv6, multicast scope should be mapped to the DNS name hierarchy. So for multicast DNS v6, we would have the FF05::FB, which is site local, would be mDNS v6 site local.mcast6.arpa. And you see it's very similar to for the link local FF01::FB, that's then mDNS v6 link local mcast6.arpa. So that is about DNS. DHCP next. Main work currently in the DHCP working group is about rewriting and updating the DHCP-v6 RFC 3315, but still other work is being done. So 3 RFCs being published since last ITF. Guidelines for creating new DHCP-v6 options and how to handle unknown DHCP-v6 options or messages. Handling the unknown messages is especially important for relay agents, what they should do when they see a message, because from an unknown message they don't know, a relay agent doesn't know whether to forward that upstream to a server or downstream to the client. That's now standardized in that RFC. And we have now DHCP options for port control protocol, PCP. Port control protocol is very similar to UPnP, Universal Plug and Play. So it's a protocol to which allows the client to talk to a DSL router or to a firewall to open specific ports. New drafts, new work in the DHCP working group is about securing DHCP-v6 with public key. This allows either a public key infrastructure with X509 certificates or a pre-configured trust anchor. And the draft allows for two public key-based mechanisms with different security strengths. One is to have strong security, meaning that either a signed certificate must be presented by the server to the client, or a pre-shared key. So if a client is using DHCP, the client tries to authenticate the server to make sure that it doesn't talk to the wrong DHCP server, and because the wrong DHCP server can give the client wrong information and redirect traffic. So with a strong scheme, the client will only talk to a DHCP server it is being configured to do. Or there's the leap of faith way, sometimes also called the TOFU principle, like trust on first use. The very first contact with the server is done unauthenticated, but after that the client learns the key material, the public key of the server, and can then authenticate the server like on a renew or rebind. So after the first contact, that server is being authenticated and nobody can interfere with the communication between client and server. Then there was a draft being presented on how to allocate shared IPv4 addresses. That is mostly interesting in provider networks in the DHCP-v4 over 6 scenario, meaning that DHCP-v4 options are sent over DHCP-v6. And this proposal allows that multiple clients can get the same IPv4 address, but they use different port numbers. So this is very similar to what's done in dual stack light, for example. Multiple clients having the same IPv4 addresses, and the first client is only using port numbers like 10,000 to 12,000, and then the second client only uses 12,000 to 16,000, like so on. The client, when requesting a lease, needs to present a tuple from an IPv4 address that it already has and the port set ID that it wants to use. And that port set ID identifies the port numbers that the client can use. And then there was discussion about DHCP privacy. DHCP can be used for surveillance, can be used for monitoring, it can be used to track users and devices, because we have fingerprints in the way how DHCP clients send the queries. So a DHCP server can track a certain machine and the movement of that machine. So the user's mobility patterns can be revealed, and also personal information may be revealed depending on what applications are running and how the applications interact with DHCP. This has been presented. There was not so much discussion in the face-to-face meeting, and more work will probably be done on the mailing list. And this one is a new draft on how to use multiple provisioning domains in DHCP-v6. This is about that IPv6 nodes can be attached to multiple networks, like a handset, a smartphone can be attached to a wireless, can be at the same time attached to the telco networks. And each network might run DHCP-v6 and might even give different data, like different DNS servers, NTP servers, and so on, and how to identify this provisioning domain and what to do with conflicting information here. And this proposal describes that then each network interface gets provisioned with the data that belongs to the provisioning domain where this interface got a DHCP connection from. Was the DHCP part, and about IPv6 in general and IPv4 sunset. We had 5 new RFCs since last time. The IPv6 multi-homing without network address translation, we discussed that, or I talked about that in the last webinar, ITF review webinar, that has now been published as an RFC. And the same is the way how to generate static network, or not network, interface identifiers, depending on the network, but being stable, but still not based on the MAC address. That has been published. Also, there is an addition to the secure neighborhood discovery sent way to securely do neighborhood discovery, and how to discover the NAT64 prefixes using the PCP protocol, and an informal RFC about NAT64 deployment, how to deploy, and the experience that the people had in the past with NAT64. New work. Important new work in the sunset group is how to tell a client that there is no IPv4 anymore in this network in order to stop useless traffic, because if a client doesn't know that there is no IPv4, it might send broadcasts like DHCP4 broadcasts all the time, and that consumes power on mobile nodes and creates unnecessary traffic. It would be nice to be able to tell a client that a certain network has no IPv4 anymore, and this draft specifies an option both for DHCP6 and for the router advertisements that with that option the network can tell a client that this is an IPv6 only network, and please not try to find an IPv4 address in here. Another document about running multiple IPv6 prefixes. Running multiple IPv6 prefixes is either having multiple prefixes of the same type, like multiple global routable addresses, so-called global unicast addresses or GUA addresses, or a mix of having a global routable and local addresses, like the unique local addresses and the global unicast addresses, and what network administrators should consider when designing such a network. And it talks about network management tools that currently, most network management tools currently are not able to cope with multiple prefixes on the same network. So coming from the IPv4 world, these network management tools are still in the IPv4 world, where there was just one prefix, one network for every interface, and with IPv6 that's not the case anymore. We can have multiple. We could have multiple provisioning domains that we have just mentioned with the DHCP. It can be a burden for the neighbor discovery cache of layer 2 switches, because there is then a larger amount of addresses that needs to be kept. That can be 10 to 20 times more data to be stored in the layer 2 switches, and if the switch doesn't have enough memory, that might be a problem. And the problem of exit router selection. The traffic back should usually go through the same route that the traffic came in, and that is not always easy. If there's multiple prefixes, the node might not know which is the best router to use or the preferred router to use here, and we can run in situations with asynchronous routing. And this document explains all the pitfalls and what to do about that and what's possible today. And this draft about the IPv6 link local zone identifiers wants to remove these zone identifiers. Today, for link local unicast communication, there is always the need to specify the zone IDs. And if you haven't used link local addresses, you see them on the bottom of this slide. The very last is an SSH command connecting to a machine with a link local address. And today you always have to specify your local network card called the zone ID from where you want to initiate the connection from. This is required because the link local addresses are only unique within one link local network, and if your machine has multiple network cards, the operating system doesn't know which network card, which zones should be used. So this proposal says that the IPv6 stack can use some heuristics to find out the interface zone ID to make it easier for the user, so that the user doesn't need to specify that zone ID. Problem with the zone ID is that the zone ID is always local to the node, so it's not possible to copy and paste instructions from one machine to another, because it's different from one Mac OS machine to another Mac OS machine. It's completely different on Linux to Windows and so on. It's a big mess. It would be better to just be able to use the IP address and go away with the zone ID. This proposal talks about how that can be done. There was some interest in the working group to work on this, so we have to see whether that advances on the mailing list and might become adopted by the working group and being worked on. And the last part on IPv6 is a report on unique local addresses at the Japan Network Operators Group meeting. And there they had multiple IPv6 networks. One was with unique local addresses, that is private addresses, plus global unicast addresses, plus IPv4. So almost everything that is possible v4 and 2 types of v6. And result here was, in that situation, at least with modern machines, modern macOS machines, the unique local addresses are not used except in neighbor discovery and multicast DNS traffic. So only global unicast IPv6 and IPv4 have been used. And then there were 2 other networks. One was with unique local addresses only, so no global routable addresses. And these unique local addresses have been provisioned with auto configuration in IPv6, and there was a NAT64 DNS64 gateway. And result here was that most applications work. Only applications that are not known to be working in IPv6 at all, like Skype, they failed, of course, because they cannot do IPv6. But all other applications like web browsing, email, Jabber, and all the other applications the presenter tried, they just worked without problems. And the second, or the last one, was a unique local address network with NAT66, a stateless prefix translation, IPv6 to IPv6, and also there most applications just worked fine. Result here was that unique local addresses don't create problems, so it's safe to use unique local addresses either alone with some translation, because unique local addresses are not being routed in the internet, so you need some kind of translation, either NAT66 or NAT64, or in combination with global routable addresses. So unique local addresses can be used and no problems have been seen. And yeah, we already out of, or almost at the end of this webinar, not out of time, but at the end. Before we go to the question and answer section, I want to point you to some upcoming Men&Mice events. I will be at the FrostCon open source convention end of August with a talk about Dane and DNSSEC. That is in German language. So if you happen to be in Germany, if you are welcome to join there. It's in near Bonn at the Rhein-Sieg University. The next Men&Mice webinar will be on the same topic. It's basically a webinar with the same content as my lecture on the FrostCon. It's DNSSEC and Dane Email Security Reloaded, which will be Wednesday, September 3rd, 5 p.m. GMT. And you can, no, 4 p.m. GMT, 4 to 5 p.m. GMT, and you can register already with that URL there, or you just go to the Men&Mice page, webinars, and register there. And there will be a full day tutorial on the very same topic, that is DNSSEC and Dane, this time again in German language at the German Unix user group, GUG, on Wednesday, September 24th, 10 o'clock to 6 o'clock. And you see the URL there, and that is in the Ruhr-Universität Bochum. So if you are in Germany and you go to the German Unix user group meetings, join me there, come to the tutorial. And let's see if we have some questions. Peter, do you see some questions?
Yes, Carsten, I see a few questions here. First, I have a question from Alan. It has to do with the distributed root zone. He asks, regarding the distributed root zone, was there any discussion of how often the new zone files would be distributed?
Not directly, so there was no direct discussions like how often they would be distributed. From my understanding is that the distribution or the provisioning of the resolvers would be the same way as DNS secondaries work today. So the root zone has a refresh value in the SOA record, and that refresh value tells the secondaries how often it should check for the root zone servers if there's any change, and then the resolvers will check for the SOA record, check for the serial number of the root zone, and if they see a change of the serial number, an increase of the serial number, they will then do an update, possibly an incremental zone transfer from one of the root name servers. There was discussion whether that would be from the real root name servers or some kind of provisioning servers, so that is still in the open. Might be that that could be some kind of provisioning service in use there.
Very good. Then I have another question from Henry. Can you give us a short overview of what has been discussed about Dane?
Yeah, as I told, the details will be in the next webinar, but let me quickly bring up my my notes on the Dane. So Dane working group. The proposals on Dane and SRV records and SMTP email are SRV draft is in the final edits and will then have a working group last call. So we will see Dane and SRV records possibly in the as an RFC or as a working group last call in the fall ITF meeting in November in Hawaii. SMTP is done, so I expect the SMTP Dane RFC to be published anytime now, so in the next weeks probably. There's then the proposal on OpenPGP, that is to store PGP keys in DNS with Dane and also SMIME certificates and secure that. That is also almost working group last call, so almost done. There was work on Dane BIS and operational guidance. There was a proposal or a draft on operational guidance, that is how to deploy Dane and what pitfalls to avoid. That document, it's getting larger and larger, and now also contains minor updates to the original Dane RFCs, and it might evolve into an update to the Dane RFC later on. Work is being started on using the TLSA resource record that is being used for Dane now with raw public keys. So instead of storing X509 certificates, be able to store any kind of public keys, raw public keys in binary format in that TLSA record. So it's not then required to create a new DNS resource record type every time some other key material needs to be stored in DNS. And there was one proposal brought forward how Dane can be used with content delivery networks. So today, the problem is customers using a content delivery network doesn't have control over the SSL keys. So either the SSL keys are given to the content delivery network operator, and then there must be a trust to that operator because that operator has the secret key, or the secret key is not with the content delivery network just on the company's website, but then the SSL termination at the content delivery network doesn't match that certificate. And Dane can be used here to fix this. And there was a proposal how to do that. And lastly, there was a discussion about reverse Dane. Reverse Dane means that the server uses Dane to validate the client. Today, Dane is being used by a client to validate the server, so the client be sure that the client talks to the correct server. Dane could then also be used on the other way around for a server to authenticate the client that the server talks to the correct client. And that is work that has just been started in the Dane working group and will be discussed further on. And more on that in more detail on the September webinar.
Very good. Attendees, you can still submit questions, but there is one more question here from Tom. Does the new SPF RFC clarify the use of text versus SPF records?
Yes. So in order to for the people on the call, for the attendees of the call to understand this. So when SPF Standard Policy Framework was firstly developed around year 2000, I guess it was quite hard to get a new resource record type. So the SPF people, mainly coming from the email world, they just used the TXT record to store SPF information. Then later, when SPF was standardized as an RFC, the DNS people in the IETF came along and said, oh, this is overloading the TXT record. The TXT record has been used for so many things. That's bad. Let's make a new own record type called SPF record, and the SPF data should only be stored in SPF records. Unfortunately, because there was already so much deployment using the TXT record, the SPF record never really got much traction in the real world. And this new RFC now about Standard Policy Framework, SPF now, specifies that SPF information needs to be published as TXT records, so plain TXT records and nothing else. That means that the SPF record type is dead, not to be used anymore. A lot of people in the DNS community don't like that decision, and this is one thing that happens in the IETF, and it's a rough consensus. Not everyone needs to be happy, but most people probably are happy, and it's a solution most people can live with, I guess. It's not ideal, but we have to use TXT records as we have used in the beginning. And we can forget about SPF record type, that is.
Very good. So, nope, there are no further questions as of now, Carsten. So I think we'll just put an end to this webinar. And to repeat myself, this webinar has been recorded, so we will upload it along with the slides to our website shortly. And you can find it there along with all previous webinars that we've been doing. So we thank you all for joining us today, and we are looking forward to having you joining us as well on the future webinars as well. So Carsten, thank you, and everyone have a nice day.
Peter, thank you. See you next time.
Bye.